Good morning, everybody. It is, be honest, it's July and I'm outside because it's a warm day and it's going to be beautiful. So my apologies if there's a little bit of extra background noise, but the mic's pretty close to me, so I don't think you're going to pick it up. And I kind of made a practice video and it seemed fine. Anyway, let's get to work. So this is video PR4. We are now talking about theoretical probability. We did the experiment with the online dice simulator and got it tossed up to 3,000 times. And, we kind of got a straight line. And I could look for it, but maybe you can look for it for me. You can find one where it'll roll the dice for 10,000 times or 100,000 times. You would find those lines to be really close to being straight, because as you do an experiment, the more times you repeat it, the closer it's going to get to your theoretical probability. So let's fill in the thing and make sure that you can remember the difference between them. And I also added a little graphic there for us. But for experimental probability, guess what you need to do? You need to do an experiment. Now that sounds really exciting, but that experiment can be as simple as rolling a dice or tossing a coin or something like that. The problem with experimental probability is it does not produce the same answer every time. So it'd be really hard to give it to you on a test and mark it, because everybody's going to have a different answer. Theoretically, you could toss the coin 12 times and it could all come up heads or all come up tails, but it's not going to happen very often. But I have to mark it right because it's an experiment, right? And the reason experimental probability is a little tough to deal with when I'm looking at your answers is it's due to randomness. Or I'm going to give you the big science chemistry word, entropy. So there's two rules in the universe, enthalpy and entropy. Entropy, which is randomness, keeps increasing, which is why if you are busy with your schoolwork and you leave your house and don't clean it for a while, it's just going to get messy. Even if you don't have children, it's going to get dusty and things are going to just get all messed up. And then you have to use some energy to reduce that entropy. So based on randomness. All right, anyway, back to math. Theoretical probability is calculated using a formula. And it does. This is the part that makes me happy. Whoopsies. Oh, I can't spell. Hold on. It does produce the same answer every time, which makes it a whole lot easier to deal with. All right, so if you remember, probability is equal to the number of things in your event over the number divided by the things in your sample space. So this is what you want. Over all options. Okay, so flipping a coin and getting heads. So we're going to make it look nice. Okay, so the probability of getting heads, see, mathematicians are really good at making shortcuts. So instead of writing all that, we're just going to do that. Is equal to, now, our sample space, if we're flipping a coin, this is our sample space, and there's two choices. It's going to be heads or it's going to be tails. Let's do that. Right, there's our sample space. So that's where that comes from. And getting heads, there's only one. That's our event. That's what we care about. Boom. 0.5. I'm okay if you leave it as a fraction, as long as it's reduced, or you can just take the easy way out and convert it over to a fraction. All right, rolling a die and getting 5 or less. So my sample space, I'm going to write it out. 1, 2, 3, 6. Okay, so in case you forget, die is a single for dice. And I guess I should have said a 6-sided die, but we're just going to assume that's what it is all the time. Getting 5. Oh, sorry. So probability of getting a 5 is going to be, now our sample space is 1, 2, 3, 4, 5, 6. 6 chances. And I want 5 or less. So 5 is good or less. So all of those ones I circled, those are my events. So there's 5 of them. And there it is. All right. Now, if this is the way we're supposed to do it. Now it looks like the same thing. You don't act. I'm not going to do anything if you don't put those numbers in there. It might become more important when we start dealing with 2 events. So not going to worry. Now rolling a die and getting less than 5. So 1, 2. My sample space is still the same, but one of the things in this section is going to be careful reading. This was 5 or less. This was less than 5. So this time we don't include 5. It has to be that's less than 5, that's less than 5, that's less than 5, that's less than 5. That's not, see, when we did that, we wanted 5 or less, and that all worked, including it. So careful reading. So 0.67. If you want, you can reduce that down to 2/3. Oh, I suspect you should be able to probably pause the video at this point and finish up the questions on the page. They're pretty straightforward. This is one event, straightforward probability, event divided by sample space. All right, picking a red card from a deck. 2 ways I'm going to show you this. And either one is fine. You can do it a nice simple way. Okay, so I'm talking about a deck. So that means my sample space is going to be 52. And we can want red. This is so sample space. This is my event. There's 26 because there's 13 hearts and 13 diamonds. So that gives me 0.5. That's probably the easiest one. You can also look at it in terms of, well, okay, I got a deck of cards. There's 2 colors. There's red ones and there's black ones. And that will also give you 0.5. Whatever works for you. This might be a nice safety net because it's cards. The event is always 52, done. Don't have to think. Okay, not picking, so be careful, there's something to watch for. An ace from a deck. So in probability, when we're talking about the complement or something or not something, we use a bar on top. When we were doing, what was it? Set notation, we used that prime. I'm not sure why they chose to use something different. And if you put a prime in there, that'd be cool too. All right, anyway, it's a deck. So there's my sample space right away. It's 52. Now, not an ace. Well, there are 52 cards. 4 of them are aces. That's going to leave me 48, right? So you really got to watch what the question's asking you for. I don't know what that one is. 48 divided by 52. 0.9. And that makes sense, right? If you're thinking about, you have a deck of cards, chance of not picking it, this should be pretty high, right? Because most of the cards aren't aces. Always think that through, right? Picking a red card from a deck. Well, there's lots of reds, there's lots of blacks. 0.5 seems pretty reasonable. Remember, probability always ranges between 0, which is not likely to happen, and 1, where it's certain to happen. Move my questions up here. Right. Picking a T from all the letters in Saskatchewan. So my sample space is going to be this. So I go 1, 2, 3. There's 12 letters now. I don't want to screw up, so yeah, double check. There's 12. And it says picking a T. So there's my event. And there's 1. 0.08. Ta-da. No worries. All right, picking a Q from all the letters in Saskatchewan. Now, don't necessarily think I've screwed up the question. It's okay. I meant it to say this. My sample space is still 12, but if you go to look, there are absolutely no Q's there. So there are 0. I said that, sorry, having a moment here. Probability runs from 0 to 1. So here's an example where it's 0. No, there aren't. The probability of picking a Q out of that is 0. It's not going to happen. All right, last one. There are 15 students in a class, and 6 of them are from Coacatus. What is the probability of student chosen at random? Yep. Trying to mess you up. All right. What is sample space? How many students do we have to choose from? Exactly. Here we go. So there's 15. Oh, were you yelling at me? I forgot the bar because I want not Coacatus. So if there's 15 altogether and there's 6 from Coac, that should leave me 9. So it's going to give me 9 out of 15, which I don't know. Oh, 0.6. Ta-da. So theoretical probability is pretty sweet. You're going to get the same answer every time. And it's always going to be event over sample space. So how many you have to choose from, and then the ones you want. I don't know how to explain it. Other to me, that makes more sense. What the question is asking you about. And every one of my answers is decimal, less than 1, check. When you're doing these, I would like to see this. Oops. Show me the numbers. Show me the fraction. I don't care if you don't reduce it and just flip over to a decimal right away. But if you just give me 0.84 for an answer, say for this one, I can give you nothing. I don't know where that number came from. But if you give me this and then have that afterwards, it's like, yeah, they know what they're doing. They just messed up with the calculator. So always, I want to see you using that formula where you're looking at your event over your sample space. All right. I'm hoping you don't find the background noise too distracting. And let's finish up this video. All right, I'm having technical issues. Sorry. Have a lovely day.